pass2 of assembler. In this video, I will discuss pass2 databases and the flowchart of pass2 So pass2 of assembler. pass2 of assembler. We know the purpose of pass2 is to generate the code, evaluate the fields and the generate code. The purpose of pass2 of assembler is to evaluate fields and generate object code. That is the main purpose of the pass2. It is used to evaluate the fields and the generate object code. This is the pass2. Now the databases of pass2. Databases of pass2. Databases of pass2. This is the databases of pass2. Number 1, a copy of the source program. A copy of the source program input is the first databases. The copy of the source program input to pass from that is the copy of the source program input. This is the first point. Number 2, এটা কি কাজে লাগে যখন আমরা pass1 যেটা তৈরি করেছে সেই কপিটা pass1 2 এর কাছে থাকবে. Number 2, location counter is the second databases. Location counter. Number 3, a table that are used in MOT, that are used in pass1, a table MOT, that is machine operation table, indicate each instruction with symbolic mnemonic, length of the instruction, binary machine code and format. A table MOT indicate each instruction with symbolic mnemonic, length, binary machine code and format. This is the table that are used in pass2. So this is the third database. And the fourth one, a table POT that indicate the symbolic mnemonic, and the action to be taken for each pseudo opcode, and the action to be taken for each pseudo opcode in pass2. This table is very useful table in pass1 as well, and these are the fixed table POT and MOT. A table POT that indicate the symbolic mnemonic and the action to be taken for each pseudo opcode in pass2. This is the fifth one. A table ST is prepared by pass1. A table ST prepared by pass1. The table ST is prepared by pass1. আমরা দেখেছি এটা pass1 এ created হয় after getting label. It prepared by pass1 containing label and its corresponding value and its corresponding value. So this is the fifth database, the table ST, that is symbol table. It is prepared by pass1 containing label and its corresponding value. This is the fifth database. Next, we need base table, a table BT, that is base table, indicate which registers. This is for registers, which registers are currently available for using or not available for drop. So this table is for occupied base table and unoccupied base table. This table is used to hold the registers that are currently specified. that are currently used. Number 7, a table BT indicate which registers are currently available for using or not available for drop. You can use this table during pass2. Next, number 7, a workspace INST that is used, a workspace INST that is used to hold each instruction, as its various parts are being assembled together. So this is the output version of this assembler, assembled together. It is used to hold the output one by one, because আমরা জানি যে every instruction is executed by one. This workspace is hold to show the output, the execution body of the assembly code. So this is the databases. আমি একবার রিপিট করছি again, a copy of the database source program. This is the input source program from the pass1. The first database is number 2, LC location counter. We know there is a table in the pass1, that is MOD table, which is used to indicate the numeric and the length and binary machine opcode and the format. Next one is POT. This is a fixed table. MOT and POT are the fixed table that indicates symbolic numeric action to be taken in the pass2. Pass1 there is action to be taken, and in the pass2 there is action to be taken. The pod is used to hold the operand opcode and the action to be taken. Next, ST table is prepared by pass1 and used by pass2, and it is used by pass2 because there is a label value in label and its corresponding value. There is the important table, is the table base table, that is used to indicate the which register are currently specified as base register using pseudo opcode and the content of this register. Using BT we can hold the content also. BT is used to hold the content, so BT table can hold the content. So this is the very important table in the pass2. And then the workspace, where all the instruction, name of the workspace is INST, where all the assembled instruction are grouped, all the assembled instruction, executed instruction are assembled together. All the executed instruction are assembled together to mean there is the output version of that code. So these are the databases of pass2. Now ever আমরা see now there is a flow chart. This is the working space of the flow chart of pass2. আমরা যেমন pass1 এ ফ্লো চার্ট করেছি, সেরকমই there is a flow chart for pass2. পরীক্ষায় সেটা খুবই কমন আসে সেমিস্টারে, pass1 and pass2 of assembler. Pass1 and pass2 mean we have to draw pass1 of flow chart and pass2 flow chart. We have to write pass1 databases and pass2 databases. So এই দুটো ভিডিও কম্বাইন করে যে pass1 pass2 সেই পুরো কোশ্চেন অ্যান্সারটা লিখতে হবে. So flow chart of pass2 assembler. এবার আমরা রাখছি flow chart of pass2 assembler. This is the flow chart of pass2 assembler. Again we have to initialize the pass2. This is the pass2, the initialization of pass2. Then read source code. This is the next step, read source code. After that we have to search the POT, and pseudo operation table. There is a method technique known as pod get to search the table. If the opcode is found, that is the pseudo operation table, from the pseudo operation table if the opcode is found, then we have to check the type. We have to check the type of the instruction. If it is DC type, declaration constant type, then convert and output constant. Next, convert and output constant. Next, we have to determine the length of data space. Determine the length of data space. This is the determination of length of data space. And if there is a DS statement, so if there is any DS statement, then directly we have to find the length. No need to convert them. If there is any DS statement, then we have to determine the length. No need to convert an output constant. Next, if there is any using statement, if there is any using instruction, then it indicate available, it indicate available base register and its corresponding value. It indicate available base register BT. If there is a drops, then indicate unavailable registers BT. So this is for available and this is for unavailable registers. This is the type checking. If the type is found, then these are the steps of this. And if the type is end, if there is a type end, if there is any type of end, then it will shows the output clean up and exit. That is clean up and exit. All assembled instructions, executed instruction are goes to the workspace, that is inst workspace. So end mean pass2 is over. If it is not found, যদি আমরা POT এর মধ্যে না পাই, mean found and not found, if there is not found instruction, then we have to find the next table, that is the MOT table. Search MOT, pseudo operation table. We have to search MOT, and there is a method MOT get. If POT is not found, then we have to check MOT, and from the MOT we can get the length of the instruction, and code. From the MOT we can find the length of the instruction and the code, binary code, that is the binary code. And after the binary code we have to evaluate the value, that is evaluate field. Evaluate mean execute. Evaluate the operand. This is the evaluation part of that operand, and during this operand evaluation there is STGET method is used. And finally all the assembled instruction one by one যেটা evaluate হচ্ছে, that is evaluate all assembled instructions, assembled together the parts, of the instruction, assemble together the parts of instruction. This is the final part of this every operation code. Then we have to update the LC for the next line. Update LC. Every time we read an instruction from the assembly code, it is updated after getting the result, after getting execution of that result. When we check there is any DC, statement, then it goes to update PC. If there is any available base register, then it goes to the next part of the LC. If there is any unavailable register, then it goes to the next part of the LC. Next part mean after the LC, and after the LC it goes to the read source code again. এই প্রসেসটা চলবে কতক্ষণ অবধি, ততক্ষণ অবধি এন্ড পাচ্ছি। ইফ দেয়ার ইজ এন এন্ড, দেন ক্লিন আপ অ্যান্ড এক্সিট। আর আমরা আউটপুট কোথায় পাচ্ছি, দ্যাট ইজ অ্যাসেম্বল টুগেদার দ্য পার্টস অফ দ্য ইনস্ট্রাকশন। এখানে ইভালুয়েট হচ্ছে, দেন অ্যাসেম্বল টুগেদার। এভরি টাইম দিস স্টেপ ইজ ফলোড। তো এটা হচ্ছে পাস 2 অফ অ্যাসেম্বলার। দিস ভেরি ইম্পর্টেন্ট ফ্লো চার্ট। তো রাইট দিস ফ্লো চার্ট। First of all, initialization, read, then search the port code. If it is found this type of instruction, DC mean convert an output constant, and then the get length and update the PC, update the location counter. When there is any DS statement, then just goes to the determined length, and determined length will move to the update PC. And if any using, then available base register, and there is drop unavailable base register. After the unavailable base register, it goes to the next step after the LC. and when ALC is done, it goes to the next line of source code. It goes to the next line of the source code. This process will continue until unless the type is found end, otherwise it will execute this way. So this is the pass2 of assembler. This is pass2 of assembler.